The space industry is busier than ever, but in the last decade or so, it's all just being about the US, China, India making all the big headlines. But lately, you might have heard that Europe is getting a lot busier now. Although it can be a bit confusing with all of the companies and whatnot. So here at NSF, we said, hey, let's do a series of live streams called Europe's Future in Space. And, the way that we do these shows is we bring people from the European space industry here and we give them the metaphorical stage to chat with us. You let you, our audience, also are able to know them better. And in the meantime, it sort of works as a way for them to explain all the cool stuff that they're working for Europe's Future in Space. Roll the intro.
And here we go. We have liftoff. Propulsion continues to be normal.
R68 chamber pressure looks good.
Following up. Roger, planet.
Water towers fly! Yes!
Tango down to nominal.
Flight downside speed off. Bring in SPD off. Off. It's orange!
Orange 25! Oh my god!
Décollage. Put that in the big bag,
343 unfolds to go.
Indeed.
We rise together, back to the moon and beyond.
This methane will be igniting with the flare, correct?
Yikes. You bet. We don't need any more of these.
Hello, everyone, and welcome to NSF Live. We are here on the 4th episode of Europe's Future in Space. And, we've had launch companies, we've had a live stream company from space as well. And we have today another launch company, MaiaSpace. We have here the CEO of the company, Yohann Leroy. Thank you for being here at NSF, Yohann.
Hi, Alejandro. Thank you for the invitation. It's a real pleasure for me to spend a moment with you guys.
All right. Yeah, thank you as well for being here. And, we're not going to be doing all of this, just me and Yohann. Of course, we're going to have you, our viewer, here as well. We have some questions already prepared, sort of to not be in a vacuum, so to speak. But if you have any questions, though, you that are watching here live, you can tag at NASASpaceflight in chat, and we're going to have Ryan Caton in the background picking all of those questions and sorting through them. And every now and then, we're going to be coming back to him and going through all of those questions, of course. And I have to thank as well Jay Keegan, because he's producing the show, pulling all the levers, pushing all the buttons to make this show work, and also have arranged some of these interviews as well. So thank you, Jay, for doing all that. We're going to go down to business, of course. We're going to start with the question that I always love to start with, these interviews that we do here at NSF, which is, Yohann, MaiaSpace, what do you guys do? Like a sort of like an elevator pitch of what is that you guys do here in Europe's Future in Space, I guess, if you will.
So if I had to summarize in one sentence, I would say that our mission is to bring to the launch pad in 4 years the first European reusable and eco-responsible mini launcher. We were created back in 2022, so our objective is to perform our maiden flight next year. And so, as I said, our mission is to develop this launcher, but not only. We will develop it, of course, but the idea is that we manufacture it, that we operate it, and that we commercialize it as well. And to succeed in this endeavor, we are today 270, maybe 272 since last Monday. So we were one back in April 2022. And so the launcher that I said was a mini launcher will have a performance ranging from 500 kilograms to 4 tons. Depending on the orbit and depending on whether we go or not the first stage. And we will perform our flights from French Guiana, and more precisely from the former Soyuz launch pad.
Okay, yeah. So that is essentially one of my very first questions, because we have all the other companies as well that have come here, and it's always like, how is it that you guys were created? And so that is also one of my big questions. Like, suddenly in 2022, there's MaiaSpace. How was that even conceived, or something like that?
So eventually, we are the result of what I would call an incubation phase,
Mhm.
3 years of incubation phase. MaiaSpace was created after 3 years of Arianeworks, thinking about the future of European transportation. Arianeworks was made of let's say, commando team of a bit more than 10 people who had that mission to think at what the European launcher or launcher family of the next decade should look like. And so, since those guys and ladies have been quite convincing, the decision was taken in 2022 to create a company which is a spin-off from Ariane Group, but that operates in a fully autonomous manner to bring into fruition, if I may say so, the things the guys from Arianeworks had imagined.
Nice. Yeah. So essentially, sort of, yeah, like a spin-off kind of thing. It sort of reminds me a bit of the groups at Skunk Works, for example, of Lockheed Martin, something like that, like trying to get together the advanced technology and everything. And I really like that angle as well. Let's talk about the launch vehicle, though. One of the things that I've obviously been researching about the company and things like that. One of the things that struck me, though, doesn't seem to have a name to it, though. Does it? Do you guys have a name to it?
We have a name for the launcher, and maybe this is the part of the thing for which we are the least innovative. So the name of the company is MaiaSpace. The name of the launcher will be Maya.
Oh, okay. That makes more sense. Okay, yeah.
But that's
So
simple for the customers, they will not make any mistake.
in MaiaSpace, like it sounds like, I actually didn't look up what Maya meant, but it's like some kind of goddess or something like that. It kind of sounds a bit like that.
Yes, that's correct. But I'm not very good at Greek mythology.
Yeah,
So,
me too.
so what I know and what is important for us is that Maya, as a Greek a god, has a link with Earth, and as I'm sure we'll have the opportunity to discuss, Earth is at the center of our DNA, if I may say so.
All right. Yeah, one of the other things as well is it's supposed to be a small launcher, right? You mentioned somewhere in the range of like 3 tons, you mentioned, right? But
What I see is that yes, the performance would range from
yeah,
500 kilogram up to 4 tons in
yeah.
LEO. Yeah.
But I look at the stats, and it's actually quite a large rocket. I see 50 meters tall, 3 meters wide. That is actually no small, at least compared to all of the, like, 4 tons, as you mentioned. It's quite a decent amount of payload to orbit. One of the things that I was actually sort of thinking about is that, how does the reusability play into that performance? We obviously will talk about other characteristics of the rocket that may play into it, but like, how did you guys sort of model the cost versus the performance? Because it looks like this is sort of tailored to some of these constellation missions and things like that, at least from the outside. And in fact, I think you guys have even an optional 3rd stage and things like that. So
Yes.
how does that sort of fit into the whole design?
So there are several questions in your question.
Yeah, I'm sorry.
That's okay. Of course, I will try to address them all.
Sure.
So first, the performance of the launcher, as you said, is quite decent. it's more than the performance of than most micro launchers that are being developed in the Europe or in the US. But still, that's a performance that remains small when you compare it with the size of the rocket. As you said, more than 50 meter tall. And that's interesting to make the comparison, and it gives me the opportunity to explain what our logic is, what our philosophy is.
Sure.
We are engineers, or I think 95% of us are engineers at MaiaSpace, but our objective is not to make the best engineering product, if I may say so. So our objective is not to extract the last kilogram of performance possible, considering the envelope of the size of the rocket. What we are looking for is making the launcher that will allow us to be the most competitive, or as competitive as possible, considering the fact that economies of scale do not necessarily play in our favor when we compare ourselves to heavy launchers. 4 tons is typically 5 to 10 times less than heavy launchers, and our industry is like many other industries. When you increase the size of the rocket, or when you double the size of the rocket, typically you do not double the cost to build it. So that's positive when you grow in terms of performance, but when you go the other way around, then it does not play in your favor. And so if our launcher is 5 to 10 times less performing than a heavy launcher, then if we do things as they are done for a heavy launcher, there's no way we will be competitive in terms of price per kilogram. So we need to do a certain number of things differently. And one of them, as I was saying, is not to take the problem as a let's say a pure engineer, but to factor in the business equation into it. And so this gives now me the opportunity to speak a little bit about reusability. So you asked the question of how reusability plays in the overall economic equation. What I would say is that it changes everything in terms of business modeling, because for a rocket of our size, the reusability gives us a huge opportunity, which is to have 2 launchers for the development cost of 1. Or to put it differently, it gives us the opportunity to adapt the configuration of our launcher to what the customer is looking for. And so we do not need to waste the first stage if the customer wants to be put into a specific orbit and necessitates only part of the performance of the rocket. If we are in this situation, we can take advantage of the unused performance to get the first stage back, and so to reduce the cost to provide the service, and as a result be competitive not only when our rocket is virtually 100% full, but also when it is only 1/3 full. And this changes completely the economic equation, as I was saying, because it allows us to be competitive on a wider market than if our rocket was not reusable. And the consequence of this is that we will have more opportunities to launch, and we will draw all the benefits coming from a higher cadence in terms of amortization of the development costs, or all the fixed costs that we incur when we operate the launcher, and to go faster through the learning curve as well, so that we can be competitive and remain competitive with time, once again, much more than if the rocket was not reusable.
Yeah, that makes total sense, right? Even if you sort of remove the cost part, with so much activity going on, and especially in Europe, that we badly need a bunch of these launchers coming up, right? That if we can have more cadence, that sounds awesome, of course. And if in turn we can also have launchers that are cheaper, then that's the best outcome for everyone. One of the other things that I was sort of wondering about is when we talk about the propellants, for example, that you guys use, you're using the Prometheus engine, which uses methane or biomethane, as you call them. We'll talk about the bio part of that later on. You have that chance. But I want to ask, like, did you guys use the Prometheus just because it was already developed, or like, you just said, okay, let's pick this up, right? Or just didn't even think of making a new house engine out of that.
So we used the Prometheus engine because it was already well advanced in terms of development when the company was created. One other very important element to have in mind when you think about MaiaSpace is that our philosophy is not to reinvent the wheel. As I said in the introduction, our objective is to bring to the launchpad a launcher in 4 years. We want to do this not only because it is a challenge, but because we consider it is a necessary condition to be viable from an economic standpoint. If it costs, if you need 10 years to develop a launcher, and so if you lose massively money for 10 years before you start generating revenues from your customers, and if you self-fund your development with private money, as is our case, then it will be a very, very, very big challenge for you to be competitive. And so if we had decided when we were created in 2022 to develop the engine ourselves, there would be no way for us to be on the launch pad in 2026. Everybody knows that what makes the critical path in the development of the launcher is the engine. And so for us, it was just obvious that what we should do is use either an existing engine or an engine that is under development. And so why did we choose Prometheus specifically? Because this is an engine that will allow us to implement reusability. It uses, it has a throttable capability that is necessary if you want to be able to slow down the first stage for it to land and stay safe, if I may say so. And it uses methane that is much easier to handle when you want to implement reusability.
Yeah, and it is precisely, we are all here probably too much of a nerd, I guess. And so that's precisely one of the things that struck me, that you use the Prometheus, but there are 3 engines, so that center engine has to throttle down a lot, right, for that landing.
Eventually, it's easier to land if you took off with 3 engines than if you had taken off with only 1 engine, because you need typically 10%, I believe, in terms of performance, or the thrust for the landing needs to be approximately 10% of the thrust to take off. And having an engine that is capable of reducing its thrust by 90% would be, I'm not a specialist in this, sorry for that, but would be a kind of very big challenge. If you push, if your thrust is generated by 3 engines during the takeoff phase, then to reach 10% of this thrust, you can achieve 10% of this thrust with 1 engine fired up at 30% of its thrust, and that's easier to manage.
All right, that's come again?
Does it make sense? Is it clear what I'm saying?
Yeah. It's still quite impressive that it can throttle down to 30%. There are not a lot of engines out there that are able to do that. So yeah, quite impressive. The other thing as well is, as part of being geeks and everything, we also like things like, what are the tanks made of? Like, are you guys using traditional lithium alloys, aluminum lithium alloys, and friction stir welding, or like, is it something that is more, just put a few rings of steel together or something like that? There's a bit of both in the industry, I guess.
So we try to make it efficient. Our mission is to make a launcher that is competitive, and we have made a trade-off, and we came to the conclusion that stainless steel was the best option. Probably not the best option from a pure engineering standpoint, or at least if your objective is to maximize the performance of the launcher. But once again, our objective is not to maximize the performance of the launcher, it's to make it as competitive as possible. And with this objective in mind, when we performed the trade-off, we reached the conclusion that the stainless steel was the right option.
Yeah, we're seeing here pictures of some of these construction of is this the booster, the second stage?
It is part of the first prototype of the first stage of the launcher, yes. This picture was taken a few months ago, so it has progressed quite a lot since then.
Yeah, we've seen that, with other companies, of course, trading off whether you have a really high tech development sort of construction process versus a little bit of a less super optimized manufacturing, trading off by the simplicity of the construction, right? And yeah, I mean, that totally matches what you told me at the beginning with the simplicity, the nailing it down to just the very basics and getting to the pad. And that's another question that I have for you about timelines. What is sort of your timeline from now to like getting to the pad, which is also in French Guiana? We're going to talk about that, of course, but yeah.
Yes. So as I said, our objective is to perform our maiden flight in 2026, and from now to the first flight, we are continuing with the logic we have had since the company's inception, which is a test and learn approach. So typically, the idea is that each part of our launcher is that we will manufacture 3 models of each part of our launcher, and so we are currently for most pieces finalizing the second iteration. And so the principle, which is inspired from the agile approach used in software development, is to build as quickly as possible MVP and to put it on the test bench and learn from those tests to improve the design of the second iteration. Test this second model that we have built, learn again from those tests to build the third iteration, which will be, in our case, the first flight model. And so from now to the first flight, and we will continue to finalize, depending on the parts of the rocket we are talking about, the second model, and start building the first flight model, test various critical points that we have identified. For example, we have built a test bench to test the separation between the 2 stages, which is a specific challenge in our case, and considering the fact our rocket will be reusable, this pushes us to make this separation at a lower altitude than what would be the case otherwise. So this creates some specific challenges that we want to make sure the system we have designed will be able to handle. And so, of course, we can make a lot of studies, but the best is to make tests. And so, yes, we've built this test bench. There's one. Yes, we can see the picture here.
That's the one, right?
Yes, we have started the test campaign for the first model of interstage system, yes, and it has been successful. I don't know if we shared with you films. No, not yet.
We
have
had
not.
previously a video of like what appeared to be a cryogenic test.
Yes, so yes, it was performed on the first prototype of our second stage. But yes, we have also videos of the
There we go.
separation test that we performed a few weeks ago. And here you can see, yes, on the screen, one of the first cryo tests that we performed on our Quasimodo, as we called it.
And if I saw correctly the date, it said July 2023. So that's like a year after you guys were made. So the whole thing about trying to go fast is not a joke. Like that's a year, right?
Yes,
To the story.
Thinking that we were able to do in 1 year typically, and of course there's a lot between performing cryogenic test as we see here on the first prototype and bringing a launcher to the launch pad. We shall remain humble, but that's a good sign to have been able to do this in 1 year. And the test zone in which this test has been performed. We have another picture. I don't know if we shared it. On this test zone at the same time, we had on different locations a Prometheus engine that was undergoing some firing tests from Ariane Group, as well as the Themis demonstrator. This is a program that is managed by our mother company, a demonstrator of stage reusability that we try to get inspired from to derive our first stage. Once again, our idea is not to reinvent the wheel, but to use the technologies that have been developed here and there in Europe. And so in July 2023, at the same time, when we performed the cryogenic test that we have just seen, we had on the test zone the engine, the prototype of the first stage, a prototype of the second stage, which means more or less our rocket in parts, just 1 year after the company was created. And that was a good sign of the credibility of the target that we have to be able to develop our launcher in 4 years.
All right. So, I have lots more questions, but I know chat has questions. So I'm going to bring here Ryan Caden to sort of, go through some of the questions. Ryan, what is chat asking about?
Well, first of all, we were talking earlier about how you're going to be launching out of Kourou, the Guyana Space Center. Tony is wondering, how much modifications are you expecting to that Soyuz pad, which you're going to be converting for use with Maia?
So thanks, Tony, for the question. That's a good question. Not that much changes, and this is what makes this is one of the interests for us to launch from the Soyuz launch pad, including from an environmental standpoint. We reuse an existing infrastructure. We do not need to throw concrete into the ground, which is good. From a sustainability standpoint. So basically what we will need and do is replace the kerosene process by a methane process. Unlike Soyuz, we will not be propelled with kerosene. We will be propelled with methane and biomethane, as we said previously. So we need to change this process. We will need also to adapt some mechanical structure on the launch pad, and we will need also a specific erector mast that we will use as a means to transport the rocket that we will assemble horizontally from the former Soyuz assembly building to the launch pad. And so where do we stand on all this? So as you may know, we have been selected by CNES French Space Agency back in September or October of last year to operate from the Soyuz launch pad. And since then, we have started the preparatory work for the methane process and for the mechanical changes I was referring to. And as far as the erector mast is concerned, we had signed a contract 1 year ago with a supplier, or I should say a partner. And this erector mast is currently in manufacturing and will be delivered to French Guiana in the course of next year, in the first half of next year.
Awesome. And speaking about propellant, we have another question here from Khaled, who is wondering, are you going to be using a super chilled propellant? So Falcon 9, that has super chilled condensed propellant to try and extract lots of efficiency from that vehicle. Are you going to be doing something similar, or are you just going to be using like standard, still very cold, but kind of standard temperature fuels?
This is something we are looking at in our roadmap, but to start with, our idea is to not use a supercooled propellant.
Interesting.
Okay, that's actually interesting. I thought you were going to say no. I was sort of thinking, because I saw that question and I was like,
I'm not saying yes, Alejandro.
yeah.
It's part of our roadmap. And so this is something we are considering. And our logic is that we want to go fast to the launch pad, and we are ready to, we need to be simple, otherwise there's no way we can reach our target. And so we accept solutions that are not optimal, let's say, from a performance standpoint. But once we will have performed our first launches and succeeded in managing the ramp up from an operation and from a production standpoint, we will seriously consider improving the launcher performance. And so we have plenty of ideas, starting with all the ideas we decided initially to discard in the interest of schedule. But our launcher, as you may have noticed, is quite modular as well. And so it's pretty easy, quote unquote, easy. We are talking of rockets, but let's say it's easier to grow very significantly the performance of our launcher. It's reasonably easy, for example, to add engines to the first stage with an immediate and very significant impact on the performance. And doing this is much simpler compared to growing the performance of a launcher that would be optimized from day one with technological choices that are very specific to the design in question. Here we are using the Prometheus engine. Just to take an example, the Prometheus engine is developed by Ariane Group, not specifically for Maia. It is developed as a 100-ton class engine in terms of thrust that could be used to propel the future European heavy launcher one day. The fact that we use this engine make our design compatible with what the future heavy European launcher could look like. Yes.
Yeah, and that was actually sort of, on my list of things that I was going to ask you. Though that will probably be getting ahead of ourselves. One of the other thing, so this rocket is obviously reusable, as you can see here, and also on the behind you also have a couple of models as well. It has grid fins, they have landing legs. We've been talking about, that thrust having to be modular and being able to throttle up and down to land on a barge. Is your plan to start doing landings out at sea, for example, on the first launch already, or you're gonna be just let's launch it and see what happens first, and then we'll start implementing landing tests and things like that? How are you gonna be baking into your timelines the part about at some point it needs to land, right?
Second option, Alejandro. So we will first launch and master launches, and we will progressively implement reusability, and we will do it with the same logic as the one we are using during this development phase for our launcher. And so potentially in the first flight or the first 2 or 3 flights, we will perform some initial testing, stage flip, engine reignition. We will try and make sure we can control the first stage and orient it and guide it to the right place. And so it's maybe 2 years in 2028 that we will try and perform our first stage landing on the barge.
All right. Yeah, that makes a lot more sense that, you know, just trying to go for it on the first try. That sounds a bit more risky. Not that anybody hasn't tried before, but it sounds a lot riskier in my opinion.
But what
And
is important at the same time, Alejandro, if I may, is that the launcher from the beginning be reusable ready. Sometimes the strategy of some other launch operators is to introduce by design, by changing the design in their rocket reusability at a later stage. This, in my view, in our view, is really suboptimal. If you want your rocket to be reusable, you need to take this into account right from the beginning, and this is what we are doing. By design, our rocket will be reusable, and we will demonstrate from an operational standpoint this capability progressively during the ramp up.
yeah, I also had another question, sort of about the conversion. So you said at the beginning your launcher is sized so that you can launch reusable, but also you can also launch in expendable mode, and so you have that capability. What will be needed to, like, is it a seamless modification, like just remove legs and grid fins and up you go, or is it a bit more complicated? I guess that you're trying to design it for the first type of thing, but yeah.
Yes, of course. And first of all, you ask the question the right way. It's not the question should not be asked like what do you need to add to your rocket to be reusable, but more what do you remove from your rocket for it to be expandable. So I like the way you put it. That's exactly it. And so typically there are two pieces of equipment that we can afford to remove if the launcher is expandable. It's the landing legs first, and the flight control bay that is at the top of the first stage, that includes in particular the grid fins. And so those are two pieces of equipment that we do not need if we are in expandable mode. So removing them makes, of course, a lot of sense, because it allows us to gain in terms of performance, but also to generate savings. Of course, it would be stupid to launch landing legs for a rocket for which we do not intend to recover the first stage.
Yeah, that would be hardware that you lose, and it doesn't make sense to do that. So you were mentioning up to 4 tons then in expendable configuration. Is that to low Earth orbit, sun synchronous? Like what kind of, and are you planning, for example, like GTO or something like that for Maia as well?
Yes, so I will try to make it clear. But so the basic idea is that our launcher is very modular in terms of performance. So as I said previously, it's kind of future-proof, and it's easy by changing marginally the design to increase significantly the performance, but for the version of the rocket that we are currently developing, the performance in SSO, sun-synchronous orbit, is 1.5 ton when we will expand the first stage, and 500 kilogram when we recover the first stage. So we divide the performance by a factor of 3 when we recover the first stage, which may sound a big penalty, if I may say so, if people have in mind, for example, the performance impact when the Falcon 9 rocket is recovered. It's more in the range of 30%. So in our case, it's more than double this impact, and it's because the initial performance of our rocket is smaller. So the impact, let's say, of recovering the first stage is fixed, and so in percentage terms, it's more when the rocket has a lower performance. And so our rocket, so in two-stage configuration, which is the nominal configuration, is 1.5 tons in expandable mode, 500 kilogram in reusable mode. And we have as an option a kick stage that adds typically 1 ton of performance to each of those two configurations. So the 500 kilogram in a reusable becomes 1.5 ton. And the 1.5 ton becomes a bit more than 2.5 tons. And then, of course, you have a different performance if instead of launching in SSO, you launch, for example, in inclined orbit. And so, as I said, our launch pad will be in French Guiana, close from the equator. And so, as soon as we launch in inclined orbit, we benefit from the slingshot effect or the rotation effect of Earth to gain additional performance. And so on a typical orbit targeted by broadband constellation operators, the orbits that allow to maximize the density of satellites over areas where there are people to serve. So typically 55 or 55 degrees inclination, the performance of our rocket is around 4 tons. So all the range from 500 to 4 tons, as I said in my introduction, depending on the orbit and on the launcher configuration.
That's great because, as you were mentioning, nowadays it's this sort of, broadband constellations with Starlink, OneWeb, and all, like Amazon as well, building their Kuiper constellation. So being able to also have a way of, Europe also being able to launch all of that is of course very important. One of the other things that I was
on this topic, Alejandro, if you allow me to jump in, it's very important to be conscious that the big constellations, the broadband constellations, will be deployed with heavy launchers. They will be deployed by heavy launchers because the operators, the constellation operators, need their satellites to be deployed as quickly as possible, because until the constellation is fully deployed, they cannot offer a 24/7 service, and this the basic for of course to provide broadband services. And so if you launch those satellites with a medium class rocket, it will probably take you much too long, and so the first satellites you will have launched will already be 2 years old or even more when the last one will have been delivered into orbit. And so the economic equation from the constellation operator standpoint does not fly. The other reason why heavy launchers should be the standard solution is the economies of scale I was referring to. Everything else being equal, the cost per kilogram is lower with a heavy rocket than it is with a small one. still, we believe that this is a market that we can address with our launcher, because our launcher is not a micro launcher, it's a mini launcher. And so with 4 tons of performance, we believe we can fight against the lack of economies of scale compared to heavy launchers, and reach a cost per kilogram, or a price per kilogram, or a price per satellite deployed that is equivalent to what heavy launchers can propose to those constellation operators. And if we succeed in this endeavor, and I really believe we can make it, then we become a solution together with heavy launcher to further increase the pace at which constellation operators will deploy their constellation. For them, it does not represent any extra cost. It's just additional launch capabilities that they can use. So there are some ongoing discussions with some of those constellation operators, and I'm pretty confident that we will go. We will have the opportunity to deploy part of their constellations going forward.
That sounds great, and I mean, even thinking once they are deployed, if they need to replace, like, I don't know, 5, 6 satellites because they are already old or something like that, that can also be a way for you guys to keep also supplying them and being able to say, hey, we have a rocket, you don't need a bigger one to launch just a handful of these satellites. Let's bring you up, and like that makes total sense as well, at least looking at this. One of the other things as well, you mentioned you guys are going to be launching from French Guiana. Are you thinking of any other launch sites in Europe, outside of Europe? Like, what's sort of the thinking?
So of course, we look at any opportunity that may arise, but we really consider French Guiana and the Soyuz launch pad, for which we have been selected by CNES as our nominal solution. And obviously, it has a lot of advantages in our view compared to any other launch pad. The fact that you can access almost any orbit. In French Guiana, you have a wide angle open over the Atlantic Ocean, so you can launch to the north, you can launch eastwards without really any constraint. Second, you can benefit from the rotation effect when you launch in inclined orbit, and if we can be competitive in comparison with heavy launcher, it's also because we can benefit from this rotation effect when we will launch batches of broadband satellites. And third, there is of course the economic equation, and here I speak a lot about economies of scale, but this is really something you need to look at if you want to be competitive. Of course, it's easier, everything else being equal, to get attractive prices from a launch pad if this launch pad launches also is used by other launchers than ours. And the CHG in French Guiana is used by the Ariane 6 rocket. It's used by the Vega rocket. It will be used by some of the European launchers, micro launchers that are being developed. And so all this helps the economic equation of the CSG, and that can better share fixed costs. Can share fixed costs with a higher number of operators, launch operators, or launches. And I truly believe this will allow us to get attractive conditions from the CSG.
Yeah, one of the other things, sort of writing along with this question as well, was so there's no secret, you guys are from France, right? MaiaSpace is a French company, but you are in mainland French, if France, if you will. Whereas this is going to be from French Guiana. Like, how do you guys, like, is there like a launch control center you guys are going to be placing there, or are you going to be controlling the launches from France? How is that going to work?
So I'm going to answer your question, but just before doing so you're perfectly right. We are a French company, but we consider our DNA is a European DNA, and the company is French, but the project is truly European, and it's very important to understand this. More than 50% of our partners come from outside of France, and it's 40% of the added value of the launch services that will be generated outside of France. And now that said, to answer your question, yes, so we will our launch operation center will be in French Guyana, and our objective is to reuse the buildings and partly the infrastructure, that is available in the former Soyuz launch pad.
Nice. Yeah, that makes sense because it's the closest that you can be, and that's sort of the best way to be able to go along with the launch operations. Yeah, don't worry about the part of the French and everything. I'm Spaniard. I'm proud of the European side of things, and just as we go here, we are like 10 minutes away from what's supposed to be the end of the show. It's kind of crazy that we're already this far along. So I'm gonna throw it to Ryan because I know there's a bunch of questions about reuse, and I know he's been grabbing some of those questions. Ryan, what are people asking in chat?
Yeah, we have got so many questions about reusability. It's kind of bonkers. So I'll get through these as quick as I can. But a lot of people are very interested in what you're up to. First of all, is your current vehicle Maia? Adrian is asking, are you going to be only concentrating on the kind of the medium lift market, or as you were saying earlier, with these big satellite constellations going to be using heavy lift vehicles? Is there going to be a heavy lift vehicle further down the line for MaiaSpace?
So our first objective and our mission is to develop the rocket I was talking about with the performance I indicated. What I said is that our rocket is future-proof. We have not taken any decision yet to grow the performance of our launcher. Our first objective is to develop and demonstrate we can operate it. If we want at some point, because there is good market response, to increase, adapt the design to increase significantly the performance, as I said, it will be quite easy. But with the current version and the 4 tons that we can reach in inclined orbit, we believe we can address successfully, from a commercial standpoint, the broadband constellation. And for our business plan to be viable, we need to have a foot in different markets. It's another way to look or to think of economies of scale. We want to be able to grasp some market share in the 500 kilogram satellite market, in the 1.5, in the 3 ton, and in the constellation. And it's by bringing those pieces all together that we will be able to make a profitable business plan.
Mm-hmm. Very interesting. We have another question here from Creative Bytes asking, we obviously saw your graphics showing a landing in the ocean on an ocean platform. Do you have any plans to do a return to launch site with a pad at French Guiana at the Kourou Space Center?
Not immediately, and certainly not with the current launcher design. The performance penalty would be much higher if the first stage had to go back to the launch pad, and the performance would be negative eventually. So this would not make sense. So no, for the time being, the idea is to land a few hundred kilometers from the French Guiana coast on a barge at sea.
Mm-hmm. Supersonic Retro Propulsion in chat. Their question is very related to their name. They're asking, are you planning with your re-entry profile? Are you planning some sort of re-entry burn or some sort of burn outside of the atmosphere to prepare for re-entry? Of course, we see Falcon 9 and Blue Origin with their new Glenn. They do entry burns, but with the Starship Super Heavy, they don't. And we see those awesome camera views where the engine section is almost, getting roasted. It's glowing hot. So, are you planning to do an entry burn, or are you just going to embrace the atmospheric forces?
Yes, the flight profile consists in performing a re-entry burn of the 3 engines before entering into the atmosphere, and then reignition of the central engine just before landing.
And a couple of related questions here. GSC Hydro asking, what is your expected turnaround time for the booster? And Spherical Cow also asking, how many reflights are you planning per booster? So how quickly will you be reusing your booster? And how many times do you expect to reuse your booster?
So turnaround time, I do not have a precise figure in mind. Obviously, the idea is to test and learn for this as well, and progressively reduce it. But from a business standpoint, it is not a fundamental parameter, if I may say so. Of course, the shorter, the better, but with the cadence that we target, and which is 20 flights per year after a few years of a ramp up, it is not essential to be able to manage a turnaround time of a few weeks only. We could afford to that it lasts a bit longer than this without impacting too much the business plan. And as to the number of reuse of first stages, so there are two ways to look at the question: the engineering one and the business one, if I may say so. And
yeah.
We take the business one. The question is how often will we need a performance that is higher than 1.5 ton, which is the performance that we can reach in SSO with our reusable configuration using the kick stage I was talking about. And so out of the 20 flights that we intend to perform per year, we believe that 4 to 5 times a year we will need the full launcher performance. And this means that we will use each first stage 4 to 5 times typically. And from an engineering standpoint, the engine can withstand 5 reuse. They are designed to be able to withstand at least 5 reuse, and we have the same logic for the first stage. Probably, if there is an opportunity, we will be able to demonstrate that we can do more reuse than this, but we don't want to over-specify the stage, or we don't want Ariane Group to over-specify the engine.
Very interesting. Alex, back to you.
Yeah, I see a lot of people are very interested about the reuse side of things. Of course, it's super cool seeing rockets land and whatever. I'm more interested. I'm a nerd of the landings as well, but the main goal of the rocket is to launch and deliver customers. Is there anything that maybe you can hint in terms of customers that maybe down the line, or is all hush hush?
What can I say on this? I can tell you, I believe it will be made public in the coming days, maybe tomorrow. We have signed our first commercial contract a few weeks ago, and so I cannot reveal the identity of the customer. But stay tuned. You will you learn very soon who they are. And beyond this first contract, we are very proud of. What I can say is that the commercial momentum is very good. We have half a dozen discussions that are pretty well advanced, and some of them for multiple launches. And what makes me very confident for the future is that we have customers, a very diverse panel of customers. We are in discussion with some institutional customers, but also with commercial ones, purely commercial ones. We have customers from Europe, but we have also customers from Asia and from the US. And we have customers who have very diverse needs as well. And this illustrates, I believe, the strength of our business model, because we can be competitive towards customers who need to launch a 500 kilogram satellite into orbit, as well as to broadband constellation operators who are looking for ways to increase the pace at which they can launch their broadband satellites. And so this, of course, we need to convert the try, as we say in rugby, in France. But yes, we have already converted one, and I'm pretty confident that we will convert additional ones in the coming weeks and months.
That's great. I'll definitely keep an eye on that announcement. I'm really, we had another company as well saying, "Oh, we have an announcement coming up." So that's really one of those things that will definitely feature probably on Friday. We have a weekly show called This Week in Spaceflight. We talk about all of the news stories of the week. So we're probably going to talk about that as well. Apart from that, I have sort of a closing question that I usually make, because the purpose of these shows is to put in perspective the European spaceflight industry, all the cool stuff. That's sort of what I said at the intro, right? This rocket, and the one that you have behind you, right, is gonna be integrating reusability in Europe, and that's sort of quite a big deal. I think not a lot of people appreciate that we don't have that capability, right? Like, I feel like at least MaiaSpace kind of fits into that equation here in Europe. So European, I like that we are embracing, innovation and trying to do these things. So do you have any comments about this? Because, I really want your thoughts about this.
Yes, so of course, we consider this is a part of our mission to make sure that Europe master a technology that is considered as strategic from a sovereignty standpoint, in terms of independent access to space. We believe the rocket will need to be reusable at some point. And so, yes, this is our mission, to bring this technology, or the mastering of this technology, to Europe. So some people explain on the other side of the Atlantic that they implement reusability to be able to land on Mars. This is not our target. We do not intend to land our rocket on Mars at some point. We want to make it land on a barge at sea, at least at the beginning, but on Earth, definitely. And we want to do it because we believe it is a necessary condition for Europe to be able to make competitive launchers. I explain why. For medium class launcher, it is more than welcome, even necessary. It allows us to be competitive on a wider market than if we had just an expandable launcher. But when the size of your rocket grows, then it becomes also interesting in terms of cost per kilogram. It allows you to reduce your cost per kilogram, and so to be much more competitive. For the case of a Falcon 9, we were talking about earlier, recovering the first stage represents typically a 30% performance penalty, but the savings it allows SpaceX to generate is higher than this. So concretely, recovering the first stage becomes very interesting from a cost per kilogram standpoint.
Yeah, and of course there's also usually like I guess that there will be two other questions that I guess I will probably ask if you were like you were mentioning the Falcon 9. They also reuse the fairings. Is that even something on the roadmap at all? It's probably complicated because you have to fish them out of the ocean, right? I don't know.
Yeah, not this one. To be frank, we look at a lot of opportunities, but we have difficulties being convinced with the fact that recovering the fairing, would make sense from economic standpoint.
Yeah,
as well as
figured
for the
that.
stage, to be frank.
Yeah, especially for a size of this rocket. It's still big, but obviously if you then try to recover the second stage, probably it's a lot of performance loss, so it wouldn't make sense. I wanted to come back to Ryan, just if we have any more questions from the chat before we wrap up. And so Ryan, do we have anything left in the queue?
One final one from Tony here, and I'll bring up Tony's question, but it's been asked by many people in the chat. Essentially, is there a roadmap for crew launches with a MaiaSpace vehicle? Is that anywhere in your future ambitions, or are you just purely focused on cargo?
We are focused on launching satellites into orbit, launching satellites which we believe can improve life on Earth. Launching people into space does not really fit with our values. We consider we want typically to reduce the environmental impact of space activities on Earth in space, and we believe sending tourists into space is a bit difficult to justify if you have this objective. So as far as we're concerned, we prefer to focus on launching satellites whose missions contribute to better understanding the climate change, or that can help reduce the digital divide, this type of stuff, but not launching tourists into space.
Interesting.
Yeah.
Alex?
Yeah, that was probably one of the apart from all the reviews, a lot of people were also asking about that, and it's fine to just focus on satellites and that type of cargo. Not everyone really needs to be launching crew, right? And so one of the other things that as well that I wanted to sort of focus as well before we wrap up is sort of like, how do you think your company sort of fits in between all of the European spaceflight industry? Because it seems to me that the way that you guys are positioned, you might have a very good chance of perhaps being the first company to have a reusable rocket in the market from Europe. Like, that would be a very big deal. Like, you guys are launching next year, right? That was sort of your goal.
Yes. So how do we compare to others? So I would say first that when we compare to others, we tend to look more at heavy launchers than at micro launchers, because we want to be competitive. This is our motto. This is my motto. I believe that if we want to be viable, we need to make money. If we lose money at some point, the story will stop, and there's a risk that it stops quite quickly. And micro launchers, I believe, will have a very difficult time going forward, because there's no way they can be competitive in terms of price per kilogram. And of course, I understand the story that the colleagues are talking about, the analogy of the bus and the taxi. I'm sure you've heard of this, saying
Yeah.
that the heavy launcher is like a bus. The micro launcher is a taxi, and it's not because the bus is several times cheaper than the taxi that nobody takes the taxi any longer. I believe this comparison, this analogy, has its limits. Because in our market and considering the size of the satellites that we want to launch, the price of the launch service represents much more than what a cab costs you when you want to go from point A to point B. And it's true that you and me can make the choice, and sometimes when we are tired, prefer a taxi over the bus. But for the satellite operator, and I've been a satellite operator for 10 years, and buying launch services before deciding to go on the dark side, on the less dark side of the industry, I can tell you that price matters quite a lot. So this is the first point. The second point is that I believe we have a very different logic compared to most of the new space players that have popped up in Europe or even elsewhere, because what we are trying to do is combine the best of two worlds, if I may say so. We are a new space company. We are a startup company, but we are also a spin-off of Ariane Group, and we try and draw the benefit of those two identities. We are autonomous, as I said, and this allows us to do things differently from Ariane Group, and we can do this because the field of constraints we operate in is different. The development of our rocket is not funded with public money. We fund it, we self-fund it with private money. But on the other hand, we can draw from the experience and the expertise of our mother company, and this will allow us, hopefully, to avoid making a beginner's mistake, if I may say so. Because at our mother company, there are people who have been developing rockets for 40 years and 50 years, and that can help us, if we want it to make the right choices or to avoid, once again, making mistakes. And so this, this logic of trying to get the best of the two worlds, in my view, gives us much higher chances than if we were to try and reinvent the wheel, as I was saying a few minutes ago.
I saw a question here. I guess it's from they say that they live in France, and if there's like internships and things like that. Do you guys have something like that on your company?
Yes, sure. The best is that they put their CV on our website, and they can go on MaiaSpace.com and drop their CV, and of course we will have a look at it.
Yeah, definitely. More people working in rockets and space flight stuff in general, right? That's always exciting.
And sorry, Alex, to interrupt.
Yeah.
You said the guys who were asking the question were French, but we do not only hire French people, and we have
True.
15 different nationalities in the company, and I believe there is a lot to draw also from this mix of culture. And so, yes, if you come from Spain, if you come from Germany, from Italy, we have already some Spanish, Italian, German, Belgian people, but you are at least as much welcome as French guys and ladies.
That's always great. And thank you for being here at NSF. It's been exciting, and one of the things that I'm going to tell you though, you should come back once you launch that rocket because I'm really looking forward to that. But
Okay,
you know,
little more than 1 year, Alex.
yeah,
Please.
and I don't know, maybe put a few cameras out there on the launch pad. I don't know, but you know how we are here at NSF. We try to cover as many launches as we can. So maybe if we can have something there, we'll discuss that.
Okay,
Just joking, but thank you for being here, Yohann, and really excited to you know get to see more stuff. I'm definitely tuning to whatever news comes out tomorrow. I'm definitely gonna be focused on the news and see what comes out. Thank you.
Thank you, Alex. Thank you, Ryan. Thank you, everybody. Goodbye.
Yeah. Thank you, Ryan, definitely for taking those questions. And it's not easy to host. It's it's the only show that I host essentially here at NSF. Every other time I'm the guy answering the questions. So for once, at least, I have Ryan here taking those questions. And thanks for that.
Wonderful as always. Pleasure to meet you, Yohann. Thank you for coming on. And looking forward to what MaiaSpace has coming in the near future.
Stay tuned.
And thanks as well to Jay Keegan for operating the stream. We'll have a lot more shows coming up soon. No spoilers, but just expect perhaps one next week. We'll see about that. We have more of these Europe's Future in Space shows coming up soon. So definitely keep an eye out for those. And until the next time, see you later.
Bye.
And here we go.
Propulsion continues to be normal.
RCPA chamber pressure looks good.
Rolling up. Roger, Atlantic.
Water towers, fly! Yes! Tango down to nominal.
Flight downside speed off. Bring in SPD off. It's orange!
R45! Oh my god! Oh my god!
Décollage! Look at this! Put that in the big bag, Eagle.
343 unfolds to go.
Indeed.
We rise together back to the moon and beyond.
If the methane would be igniting in the flare, correct?